The question says, use the trapezium rule to find the area bounded by the curve y equals cosec x between the limits pi by 6 and 2 pi by 3 for 3 intervals. So what does this mean? Let's make a rough sketch. Let's assume that this is the curve y equals cosec x. Notice one thing, this is not how the curve looks like. We have assumed that this is the shape of the curve so that it will help us to find the values we need to use the trapezium rule. And our assumption that the curve looks like this will not affect our value of the area. So this assumption is a fair one. So the limits are between pi by 6. The lower limit is pi by 6. The upper one is 2/3 pi. So 2/3 pi. So here's pi by 3, and somewhere here's 2/3 pi. So let's just join this. So the question asks us to find the area bounded by these two lines and the curve for 3 intervals. So what does this mean now? If we draw 2 lines, 1 and 2, we see that there are 3 gaps here. This is the first gap, this is the second gap, this is the third gap. Now the gaps are drawn the lines are drawn in such a way that all these gaps are equal. That is to say, the lines are equally spaced. So width of this gap is equal to the width of this gap, and that is equal to the width of this gap. And each gap is called an interval. So all these intervals are equal. Now let me write down the formula for the area using the trapezium rule. The area equals half the width of each interval, 1/2 the width of each interval, times the first height. I will tell you what this means in a moment, plus 2 times the sum of middle heights, all the middle heights, sum of all the middle heights, plus the last height. So we have the area equals 1/2 the width of each interval. The width of each interval, that is the width of first interval, is equal to the width of the second interval, that is equal to the width of third interval. The width of each interval is the same. So 1/2 the width of each interval times the first height. Now this is the first height, this is the last height, and all the heights in between, in this case 2 heights, all the heights between the first height and the last height, these are the middle heights. So it goes times the first height plus 2 times the sum of middle heights. So first height plus 2 times this height plus this height plus the last height. So the first thing we need is the width of each interval. The width of each interval is equal to the upper limit minus the lower limit divided by the number of intervals. That is, okay, so the width is equal to the upper limit, that is 2 pi by 3, minus the lower limit pi by 6 divided by the number of intervals, that is 3. This equals pi by 6. Okay, so now we have the width of each interval. Now we need the first height. What is the first height? This height. So how do we calculate this? Simple. Just put this value here. We'll get this height. In other words, this height is cosec pi by 3. This height here is cosec 2 pi by 3. By this way we can find the first and the last height. Now we need the middle heights as well. So how do we calculate the middle heights? For that we need these two values here. So the thing to do now is to calculate these two values. Now as you can see, the width of each interval is pi by 6. So this is here. This here is pi by 6. This here is also pi by 6. And this here is also pi by 6. So this value here is simply pi by 3 plus pi by 6. That is oh sorry, this is pi by 3. So this is pi by 6. So this value here is pi by 6 plus pi by 6, that is pi by 3. And this value here is pi by 3 plus pi by 6, that is pi by 2. And you can check, pi by 2 plus pi by 6 is 2 pi by 3. So this value here is okay. To move from here to here, we need to add pi by 6. So this value here will be pi by 6 plus pi by 6, and this value here will be pi by 3 plus pi by 6. I hope that's clear. Okay, now let's calculate the first height. The first height equals cosec pi by 6. That is 2. Now the second height equals cosec pi by 3. That is 2 by root 3. The third height is cosec pi by 2. That is simply 1. And the last height that's this height. The last height is equal to cosec 2 pi by 3. So let me just write this down. Cosec 2 by 3 pi, that is also 2 pi. So now we have all the values we need to find the area. Now let's put this values in the formula here, and we get that the area between pi by 6 and 2 pi by 3 is equal to 1 by 2 the width of each interval, that is pi by 6. 1 by 2 times pi by 6 times the first height. The first height is 2 plus 2 times the sum of middle heights, that is 2 times sum of middle heights, that is this plus this. So that is 2 by root 3 plus 1. First height plus 2 times the sum of middle heights plus the last height, that is also 2 by root 3. Now put this in a calculator, work this out, you should get 3.16 to 3 significant figures. So that's it. That's how you find the area using the trapezium rule. The first thing to do, just make a rough sketch. If we assume that the shape is like this for any graph, any curve you've given, it may be y equals x squared, it may be 1 by root 1 minus x, it may be sec x, it may be cos x. Whatever the curve is given, just assume that the curve looks like this. Put down the limits, the lower limit and the upper limit, and find the intervals. Just draw lines to represent the intervals. Find the values we need to enable us to find the middle heights. Then just use the formula. That's simple. Width is equal to upper limit minus lower limit by number of intervals. First height, put this value here. This height, put this value here. This height, put this value here. So, and put all the values you obtained in a calculator, and you should hopefully be able to solve the problem. So this is an explanation on the trapezium rule, and I hope that was helpful. Thank you.